Hello, everyone, and welcome. Thank you for joining me today. My name is My-Linh Truong, and I am the Division Manager for Unmanned Laser Scanning here at RIEGL USA. Today, I'll be presenting on what is behind the curtain for RIEGL's Unmanned Laser Scanners, and I'll be highlighting our new innovations in RIEGL's UAV LiDAR technology, how to streamline your UAV platform integrations, as well as optimizing your workflow from the ground up. As a quick overview, this is our current unmanned laser scanning product portfolio. Starting on the left, our most miniaturized LiDAR scanner is our MiniVux series. We've introduced this product line for several years with various model types. And because of these model types and the interest over the years, this year we have decided to streamline our MiniVux series, keeping our lowest cost entry level MiniVux 1 UAV model type, as well as our latest and greatest MiniVux 3 UAV model type, same size, weight, functionality, but it has 300 kilohertz laser pulse repetition rate for a very cost-effective unmanned laser scanning system for your usage. Moving on up, we have our well-established VUX 1 series, which is our VUX 1 UAV and VUX 1 LR. Both are the 22 edition series model type, same size, weight, and functionality as its introduction in the marketplace years ago, except it has even more capability, 360-degree field of view, and up to 1.5 megahertz laser pulse repetition rate. So really a turnkey laser scanner for all of your data acquisition needs for ULS. Moving on up as well is our VUX 120 sensor type. It is my personal favorite, given its small form factor at 2 kilograms and has a very unique scanning mechanism called NFB. Even further, as a much larger type, which is our VUX 240 sensor, has a 75-degree field of view, and its long-ranging capability, although still lightweight at 4.1 kilograms, provides the unique optimization of UAV, but also higher altitude manned, low altitude, but higher altitude compared to the typical small UAS integrations. And that provides high detail mapping for a variety of applications. So you can see here that we have a few gaps in our image, and that is why I'm very pleased to announce our new innovation, the VUX 160. The VUX 160 itself fits directly in between the VUX 120 and the VUX 240 sensor types, and it was especially developed for fixed-wing UAVs with the ability to fly even higher in altitude, fully integrated IMU GNSS system. And to round out our ULS product portfolio, last but not least, is a lighter weight version of our topobathymetric system, the VQ840GL. This lighter weight version is of the established VQ840G, same water depth penetration capability, but now it's lighter in weight at under 10 kilograms, and this provides an increased flexibility for a variety of platform integrations for your topobathymetric scanning needs. So the new RIEGL VUX 160, as with the VUX 120 sensor, has a field of view of 100 degrees, a very unique scanning mechanism of NFB, which stands for nadir, forward, and backward. This particular sensor type, however, differs in that it has up to 2.4 megahertz laser pulse repetition rate. Very high density. This provides up to 32 targets per laser pulse. It is incredibly lightweight given its capability at 2.65 kilograms or under 6 pounds. And it supports up to 5 cameras. So the RIEGL VUX 160 is really and truly versatile, lightweight, designed for UAV as well as airborne applications. So this provides a high density point cloud, ideal for quarter mapping. It's high density resolution and extremely high multi-target capability of up to 32 targets is great for penetration through dense forestry, and with the NFB scanning mechanism really provides an unparalleled completeness and data capture with one flight pass. And what do I mean by that? Let's dive into detail the NFB scanning mechanism. So typical airborne LiDAR you would see at nadir. Here we have in false colorization the green. But with NFB, we also are capturing forward 10 degrees, shown here in the blue, as well as backward 10 degrees, shown here in red. And as you can see, with one flight pass, we are not only getting the tops of the roof and the pylon, but we're getting the facades on either side with one flight pass, which really provides a complete data set. And this is truly powerful in complex environments and complex terrain, as well as deep canyons and valleyways. So if you were to take this scanner and fly it at its highest laser pulse repetition rate at 2.4 megahertz, what type of density can you obtain? In this example, flying at your max AGL for small UAS applications, which is 120 meters or about 400 feet here in the US, flying on a fixed wing at 40 knots, which is about 18 meters per second, you can get an average point density with one flight pass, 340 points per square meter. Diving into detail, that's about the sensor type. But of course, it is also fully integrated, can be fully integrated as a system from RIEGL. And if you opt with this, we integrate with the Applanix AP Plus series INS GNSS solution, and the AP Plus board stack is fully integrated inside the scanner itself with the external IMU, and this alone is at a weight of 3.15 kilograms or just under 7 pounds. With this, we offer the AP Plus 50 or the AP Plus 30 IMU GNSS solutions. They are of the same weight, but here you can see the accuracy differences between the two, and that results in the overall data quality that you would obtain raw from the ground. Of course, that's not the only aspect. You can, of course, integrate cameras, and the VUX 160 does support up to 5 cameras. And this provides truly a full integration of nadir and oblique camera configurations that provides a variety of installations that you're looking for your mapping needs. Here we have an example system set up with a nadir phase 1 IXM camera in the front orientation, as well as forward and backward oblique cameras using 2 Sony A7R4 cameras, as well as our shock absorbing plate. So this would be your turnkey integration to mount onto your aerial platform. So let's see this system in action. So for those of you who are asking on how can you get your hands on the VUX 160 and when is it available, definitely reach out to your local RIEGL distribution partner or OEM integrator. And this particular sensor type, we're looking to hit the market at the end of Q1 of 2023. So in light of 2023 and the capabilities of our new VUX 160, I'd like to address the improved RIEGL VUX 120 23 edition. So the new VUX 120 23 edition, exact same size, weight, dimensions, mounting points, still supports up to 2 cameras. However, it too has the increased laser pulse repetition rate of up to 2.4 megahertz. And it too also now captures up to 32 targets per laser pulse, as opposed to the up to 15 targets before. And this is the new standard configuration of the VUX 120 going into 2023. Now, for those of you that have a VUX 120 and you're wondering how you can get the up to 2.4 megahertz laser scanning capability, this would be a service upgrade onto your sensor. And this service would need to be done at the RIEGL facility in Austria, where a firmware upgrade would be applied. It would undergo an internal recalibration, alignment, and system bore site calibration for your scanner and IMU and camera if you had cameras. The sensor itself, as far as the eligibility, the pricing, and the scheduling for that service availability will be provided at a later point in time. So if you are interested, in the meantime, please coordinate directly with your local RIEGL distributor office or your OEM system integrator with your scanner serial number for further information as soon as it is made available. So with the new VUX 160 and the VUX 120, how can you decide which one is for you? Really, there are minor differences between the two, but they are of note to mention. The 160 is really and truly slightly larger in height and length. As well, it has a much longer ranging capability for your scanning needs, as well as it's slightly heavier. So if you had a mounting integration already designed for your VUX 120, please note that you cannot use the exact same for the VUX 160 as for weight and balance. The mounting points are slightly different for your integration needs. So in comparison, it really does depend on your application and your overall operations to decide between which model type makes the most sense for your usage. By comparing the range performance between these two scanners, it's clear that the VUX 160 is capable of measuring about 70 up to 82% further than the VUX 120 by using the same laser pulse repetition rate. However, a small UAS platform, you are limited to legal regulations. So the additional weight and that longer ranging capability of the 160 may not really suit your needs. So I would really consider the 160 if you need to fly higher or you really need more than 2 cameras to be integrated into your system configuration for that to be the best model type for you between these two. Now, if we take it back to our small scale mini VUX series, we have a few optimized configurations for you. Our lowest cost, entry level, get you operational out the door would be the mini VUX sensor type with a Planex's APX15 IMU GNSS solution. This particular IMU also includes a DMI interface, which stands for Distance Measurement Indicator, which is utilized in the mobile mapping world. This particular sensor type in its lightest weight configuration gives you a total system weight of 2 kilograms or 4.4 pounds. This can be easily operated onto very small UAVs such as the DJI M300, which we also offer an integration kit for that, as well as other small UAS platforms that have a low payload lift capacity. Taking it a little bit further with the Minivux and the higher grade APX20 IMU GNSS solution using the new IMU 90, this very lightweight IMU type provides higher accuracy over the APX 15 at a slightly heavier weight at 2.3 kilograms or just over 5 pounds. It too also has the DMI interface, and that fully goes into our single-headed, cost-effective mobile laser scanning solution, our VMY-1. And this provides that quick return on your investment between a dedicated UAV LiDAR as well as dedicated mobile mapping LiDAR. And last but certainly not least is our well-established Minivux with the APX20 IMU as well, but this IMU is the IMU 82 at a heavier weight. It is more optimized for higher altitude. If you're flying at 100 meters or more, then this IMU 82 type would be more beneficial for your integration. And this is a total system weight of 2.5 kilograms or 5.5 pounds. So either way, all of these model types still very lightweight for a variety of UAV acquisition. So I've mentioned our product lines and our economic solutions offering of these various integrations. I also want to mention that the Minivux series, as well as our long established, which was the first in the market and really established an entire VUX and Minivux series, our VUX 1 UAV model type, all of these are now offered at an even more reduced, attractive, cost-effective price points. So this really provides the most economical RIEGL UAS solution for your operating needs. If you don't have a RIEGL UAV LiDAR, now is your time. If you haven't seen a price on the Minivux or VUX 1 UAV this week, then you haven't seen the new pricing. So definitely reach out to your local RIEGL distribution office or preferred OEM integrator for your Minivux or VUX 1 UAV system. So once you choose your UAV LiDAR configuration, you have it fully integrated, you got to put it onto a platform so you can fly and collect those projects. We have worked with a variety of UAV vendors, vetting these industrial grade, high quality commercial platforms, fully integrated, working with these vendors. We also have integration kits that are optimized for the DJI M300 or M600 for those that are still operating that platform, although it is reaching end of life. All of these bits and pieces will provide all of the parts that you need to mount it onto a variety of platforms that can be retrofitted, as well as we can work directly with you and the UAV vendor to provide assistance for the integration so that you can be operational to capture your projects. So you have the hardware. How do you operate? I would say that our steps to success would be the following workflow that is really from the office, in the field, and back in the office, or honestly, depending on your computer, you can process in the field as well. So before you go and capture your data, you got it in your office, your project planning, mission planning by using our free utility called RIEGL. You'll then pre-configure your laser scanner and camera using the RIEGL embedded desktop version. Then when you're out in the field, you're doing your field checks for your aircraft, you're checking your configuration and setup on the scanner itself by using a Wi-Fi connectivity, or RIEGL embedded web interface. No cables are needed for connectivity. Then you're ready for data collection. Go ahead, as soon as it boots up, you can within RIEGL Embedded, you can configure your scanner to auto start and collect data upon boot up and initialization, which provides one raw data file, which can then be split once you're back in the office for post-processing. So that really provides a turnkey workflow for your pilots and operators. As soon as it turns on, you know you're capturing data, or you can control the data that is being captured by implementing the PWM signal, which will allow either in the autopilot of the drone or on the transmitter on the drone platform itself, you can toggle between capturing data for all of your flight lines versus not when you're in transition. That's your choice, and you'll have those lines auto split already. You'll go ahead and check your mission log within the RIEGL embedded web interface again while the aircraft is in the air. And then upon landing, by implementing the motion shutdown sequence within RIEGL embedded, the scanner will automatically shut down, and then you go ahead and swap out the batteries as needed, and you can go ahead and fly your mission and continue on. Alternately, if that's the end of your mission, then you can download the data from the scanner, either from the onboard SD card or the solid state drive, depending on which sensor type that you have. Process the data and georeference it through the RIEGL RIE process workflow and RIE Unite to georeference it and calibrate the data. Apply our data adjustments and registration using RIEGL's RIE Precision UAV that allows for relative accuracy alignment, absolute accuracy alignment if you have ground control points. If you have camera integrated, you also have the option of colorizing your point cloud. So in the end, prior to data exporting, you have a fully georeferenced, precisely aligned, and optionally colorized point cloud to export to bring into a variety of third-party softwares for all of your feature extraction needs. Thank you so much for joining me today. And if you have any questions, please let me know. We look forward to working with you and seeing how RIEGL can assist your business. So I think we have a few moments for some questions. We have a question on list prices for the various sensor models. Please reach out to your local RIEGL office, depending on where that is, as the prices will, of course, vary around the world, given the currency. We have another question if the VUX 160 would work as well as the established VUX 1 UAV for wide area. And I would say absolutely, it really does depend on your application. I mean, you did say wide area. I would say that there is a weight differential between the VUX 160 versus the VUX 1 UAV. The VUX 1 UAV sensor is slightly heavier. However, the VUX 1 UAV also has a 360-degree field of view, whereas the VUX 160 is fixed at 100 degrees field of view, but it does have that nadir forward-backward scanning. So there is a trade-off, as well as the VUX 160 has a longer range. So I would make it there is a relationship between the two, as well as your typical applications that you would use the sensor types for. Of course, there's also a cost differential, so that would be a conversation with your local RIEGL representative. And I believe that is all the time we have for today. I want to thank you all for joining me this morning if you're here in the US. Good afternoon if you're over in Europe, and good evening if you're over in Asia. Thanks so much, and I'm looking forward to discussing with you further all of your application needs and getting you into a RIEGL LiDAR UAV solution. Thanks so much. Bye-bye.